Hello, today is March 12th, Saturday, a beautiful day. We are going to have a field trip to Lake Zhuang. Here we start from the Saigon Public Pier and we will take taxi to go to the site, including 40 minutes hiking. Okay, are you ready? Yeah. Okay, let's go. After 20 minutes of taxi driving, we arrived by Shao. This is the start of the trail to Laizhizhuang, 2.8 kilometers, about 1 hour hiking. So let's go this way. Yeah, here is a small hotel. It's called Baishao Youth Hostel. Now we are passing the Laizhizhuang village. Now you can see the beautiful small creek. All right, finally, after passing the Laizhizhuang village, the Laizhizhuang site is over there, only less than 100 meters to go. Well, finally we arrived at Laizhizhuang site. You can take a look. This is the Laizhizhuang public pier. There is some construction work going on here. Laizhizhuang, Hong Kong Global Geopark. Here we come. Here we are standing at the Laizhizhuang site. Laizhizhuang is a seaside location on the south shoreline of the Taller Channel. You can see that is the Taller Channel. We have the public pier here. So the Laizhizhuang formation starts from the public pier to the west, stretching about 130 to 180 meters. This is a site of very interesting geological study. Here you can see, for example, the fault, folds, and the beddings, and also some quite unique layers of rocks which has volcanoclastic characteristics. We will see tuffets, volcanic tuff siltstone, and also a very special chert layer. All right, let's go to take a look of this type of rock here. You can see a thick deposition of the volcanic rock, which is called tuffet. So the tuffet actually contains around 25 to 75% of volcanic ashes. It is pyroclastic rock, but also it contains some fragments of rocks of different size. So that's why we call it tuffet. The tuffet has relatively looser texture when we compare with the tuff. So you can see in this site, the tuffet are kind of weathered. They turn into the whiter or the reddish brown colors. So I can maybe use my hand to break them into small fragments. This is clearly weathered into the grade 4 rocks. All right, so let's take a look around all this location. They're all tuffets. You can see tuffets, once it's weathered, it become a reddish and a brown colored. The reddish and brown color because the iron contained in the mineral will react with oxygen and become oxidized iron oxide. So let's walk around here. All right, this is the weathered tuffet. Pretty beautiful, has different colors. We see red color, we see white color, and the yellow-brown colors. They're all due to the weathering process. Okay, let's walk around the shoreline. I'll be very careful. Rock here is very irregular. Mind your step when you walk along this rock outcrop. You can see there, this is very close to the shoreline. Did you see this green colored? All right, this is due to the microorganisms from the ocean. So now I'm standing in front of the information board. It summarizes the major rock types at this site. As I mentioned, we have volcanic tuff, we have tuffet, marlstone, siltstones. So the rock was formed during late Jurassic period, about 146 million years ago, when the Hong Kong experienced violent volcanic activities at that time. So here is a summary of how all the rocks are formed. You can zoom in closely. So volcanic eruption generates a massive volcanic ashes. So after eruption, so the ashes will float with the wind and ended up in the nearby lakes and a river. So this location is kind of a depression location forming a certain type of lakes. So the river water will keep bringing other volcanic ashes and silt into the lake. So where the pressures will compress the volcanic ashes into rock. So during this formation process, also the site experienced quite a lot of activities, such as earthquakes, which will generate folded, tilted, and faulted rock layers. So, finally, this type of formation was exposed to the surface. So it became a very special geological site, the Hong Kong Geopark here. All right, so this is a brief history of the Lake Zhong Formation. So we can come to this site over the land, and we start from the Saigon Public Pier here. We will go along the shoreline, and during the trail, we will see many features, such as some folds, some kind of bedding structures, and quartz veins, and pebble beach, etc., although to the end. So altogether, this hiking trail is less than 200 meters. Okay, so let's go together. All right, we arrived at this interesting outcrop. Actually, this is completely decomposed tuffet. I say it's completely decomposed because the weathering significantly weakened the rock, so I can squeeze it into powders using my hands. So interesting, you can see original joints and also the iron oxide surrounding the rock body here, forming interesting patterns. So completely decomposed tuff actually still preserve original rock textures. So above it, we see the more weathered residual soils, we call it, because rock texture here was completely destroyed. So I will call this one is a grade 5, completely decomposed tuff, and this one is a grade 6 residual soils. Very interesting outcrop layer. I show this sharp contrast between these two weathering grades. Okay, this is very similar to that side. So you can see completely decomposed tuff. It's very weak. And also on the top, there are residual soil layers. So the interfaces look like here. Okay, now we arrived a very interesting layer of the rock here. You can see the bedding is well developed. Actually, this is called tuffiferous siltstone. The tuffiferous siltstone is very unique in this site because it contains the both volcanic and also sedimentary characteristics. So the tuffiferous siltstone were formed when the volcanic ashes and dust settle in the water, in the lake. So they sedimented, so the forming kind of a sedimentary layers, we call it bedding. You can see the layers was quite horizontal in the beginning when they were formed. But now you can see they were overchanged. So here we can see the particles that form this siltstone layer are quite fine ashes. After settling in the water, they obtained the sedimentary rock characteristics. So we call this one called volcanoclastic rock. So we can bring here to take a look. Again, you can see stains accumulated along the joint. So this rock is graded, is weathered to at least grade 4. Let's walk around here. From this location, you can see the beautiful tuffiferous siltstone. The bedding was well developed. The beddings in the Leizhizhuang formation is well developed. Here you can see the tuffiferous siltstone. contains very thin layers of a white layer, black layer, white layer, and black layer again. So this alternating pattern shows so-called rhythmic bedding. So these alternating colors and structures actually demonstrated, for example, seasonal dry and wet season, the volcanic eruption and calm period, etc. So they represented the deposition environment at that time. So also you can look at this, the bedding layers. They were initially horizontal, and now they are tilted to around 40 degrees to the south. All right, let me go ahead. Okay, this is a very interesting layer. Essentially, they are also tafixious siltstones. But this layer is special because it is very hard. Actually, they underwent a different process called certification. So when the ashes settle down in the water environment, form tafixious siltstone, actually silicon oxide, this is so-called silica, SiO2, was also infiltrated into water. So this silica-rich underground water will infiltrate into the void space of the siltstone. So the crystals settle out in the void, filling the void, and completely changed the texture of this rock layer. It becomes very hard. It's called tafixious siltstone. So you can see if I struck with my hammer, this tafixious siltstone show a ringing sound. It's indicated that it is very dense and very stiff with very little voids there. So you can zoom in to take a look at this. This tafixious siltstone layer still preserve original bedding structures. But now it become stratified. How we can identify the stratified layer? The stratified rocks are very strong. And when you break it, it usually forms very sharp corners. So Asian people learn how to use this chert as a cutting tools in the old times. And also fracture can be developed in this stratified layer because the material is very brittle. It can easily fracture and forming sharp edges. But still, you can see original rock bedding layers. Even the material is stratified. Let me also bring here as well. You can see the beautiful the beddings are still preserved, although the rock is very hard. So when I strike this very hard rock using my hammer, although I cannot break it, but you can smell something like explosives. It's said that the more silica content, the more smell like explosive. This is because striking the rock with my hammer will generate sparks, and the spark react with the rocks will release some chemicals and smell like explosives. So very hard rock. As a comparison, you can see this layer on the bottom, the same type of layer, but they are not certified, so they are completely weathered. So because certification actually brings the material to a very strong layer, so we can also see a different phenomena called differential weathering. You can see this layer I'm sitting on has a higher resistance to weather, and the layer on the bottom show a easy weathering capacity. So in the end, so the harder material will remains. You take a look at this, you can see very clear the hard material is more weathering resistance. This is called differential weathering phenomena. Okay, from this angle, we can clearly see an interesting feature called angular unconformity. You can look at this sedimentary layers. The strike direction is along this direction, while these layers strikes along a different direction. These two form an angle. So this is called angular unconformity. The process to generate angular conformity was that the lower layer was overturned, so they form an angle other than the horizontal direction. So the new layer was formed on the top to form this angular unconformity as shown here. A very interesting location. Okay, we just stop here. You can see we come across a very different rock. This rock has a very fine texture. I can easily scratch it, using my hammer. So this is so-called mudstone. Mudstone has much finer particles, and it can be easily scratched because it's not very hard enough. So let's go. At this location, you can see a very important feature called folds. You can see this layer go all the way and make a small turn and go to the water. So this turning back and forth, which is called a fold. Fold was formed when there's a earth movement which generates compressive force to bend the sedimentary layers into the curved shape. We call it fold. So in Leizhizhuang, we can see a lot of folding structure, even within a small range. So the folding is very intensive in this location. When the tide is lower, you can see more about this folding structure. Here we just see from the surface. You can clearly see the layers actually make a turning. And this layers as well go here, along here. This go here as well, folded. Okay, let's go. Here we can see the stratified siltstone layer, very strong. And this is the mudstone layer, which is quite soft and smooth. So this whole layer will go all the way and make several folds in the water. Again, here you can see significant folds over this small area in that direction as well. Okay, here is something very interesting. This place, you can see the rock is heavily fractured. But within the fracture, there is something white and very hard. This is called quartz veins. When the rock is fractured, the underground water is saturated with silica, SiO2. The silica infiltrated and also crystallized within the rock fractures. So end up with very fine hairline-like quartz veins. Because quartz is stronger, resistant to weathering. So they will protrude it from the rock body, while other places are weathered more heavily. So you can take a closer look at this beautiful quartz veins. It is like the cheese on the top of a rock. To me, it's more like a work of art from the nature. The most beautiful place. Okay, we can turn around here. Again, clearly this is artificial siltstone layer. Look at here. Some small voids is generated and a fractured due to the Earth's movement. Now I also see a very interesting place over here. You can stop here, okay. Now you can see this layer, okay, they were initially, horizontally deposited. Now you see this part actually has a relative displacement. You can see it's due to the fault movement. This is the fault line. So this part moves up, or this part moves downwards. So generate relative differential movement, which can be clearly seen here, right? So this is a fault movement. I clearly show this site. Very interesting. Okay, let's go forward. Now I think we almost reached the end of this trail. Beyond this big pebbles, there will be the pebble beach, etc. So we just stop here for now. Okay, let's go back to the pier. We walk back along the way and we can see all the features again. Here, you can see a large folding embedded in the mudstone layer stretching to the water. Again, here is a folding structure. Look at this folded rock within a short range. So the folding can be large or small scale on this site. Here we see conformity between two layers. And we come across this certified soapstone layer, which is highly resistant to weathering. So they stand up among the other rocks. This place is most beautiful and colorful, well-bedded, tufaceous soapstone. Now we come back near the pier, where we can see a large body of tuffets. They are weathered. This location we see the completely weathered tuff. Weathering gives the rock many beautiful colors. All right, this is the end of our field trip. Hope you enjoyed it. This is Professor Gan Wang from HKUST.
And this is Matthew.
This is Riley.
This is Yvonne.
This is Kamran.
This is Horace.
Okay, see you next time. Bye-bye.
Bye.